This is a talk that I've given multiple times during the last, I'd say, 9 years or so. I've been using Mongo since version 1.8 and 2.0, really in production. The first version is 2.0 that I used. We're now up to version 5 as of a month and a half ago. But I still find that it's a very interesting kind of talk to give. There are always new people who are learning Mongo, and always folks that come from a relational background or other NoSQL infrastructure type databases that have come across Mongo at work or heard about it but haven't really used it. So the world is big, and I kind of stick to the basics, and it's always interesting to talk to people and see what is interesting, what is different about this than other things we might think or get used to with other databases. So MongoDB, as its name implies, is a database. It is not a infrastructure, meaning that if you look at some NoSQL infrastructure, everything from files, flat files, RDSs, whatever, on on storage to infrastructure such as queuing mechanism, the Kafkas of the world and things like that. Those are not meant as databases. Sure, they'll store data, even Elasticsearch. It will store data, but it is not meant as a database. It was designed as a search engine. It's sometimes more difficult to draw the line between what is a database and what is not. Here, I'm just drawing the line between what traditionally relational databases did and what Mongo is trying to do. So in the yellow dotted circle here are features, or I would say traits of MongoDB database, what it's trying to address and touch, and things outside that circle, it's just not. So it's not trying to be a relational database. It's not trying to be a relational database replacement one-to-one. It is a replacement for functions. It is a replacement for what you can achieve with a database or what you can achieve with infrastructure that supports your business. So, relational databases could be made very fast. Mongo could be made very fast. The relational databases, more saliently, are table-oriented, and they are oriented towards solving a general problem of modeling the actual world into schema that can fit aspect-oriented querying. You can come at the table with any query you want, and then in your mind think, okay, this is the data model I queried. According to this query, you change your query, you change the data model, right? If you join two tables, you get a certain shape. If you join other tables, you get a different shape. With MongoDB, it's very different. They're talking about document-oriented storage, which means that your data is stored as a document and not as tables. That is crucial to understand. If you don't do this, if you don't take that approach, then you're likely to run into performance problems if you try to impose table thinking to Mongo, as well as you're not going to be able to get all the flexibility you get from RDBMS from Mongo, so you're not going to really enjoy using Mongo if you're thinking in tables. So what is this about documents? So a document is a bunch of data fields that live together and are stored together. So for example, if I have a student and I have grades, I might have two tables, a table for student, a table for grades. And I might have many more tables, but I would store this student grade across two tables, right? The student information in the student table, the grade information in the grade table. In Mongo, I might store a student as a single document containing within it all the grades for the student, under the theory that when I want to look at the student and know the grades, I will just fetch that document and I will have everything I need. As a result of not storing tables and going document-oriented, there is no referential checking. There's no referential integrity between two separate tables. Well, there are no tables, there's collections in Mongo, but there's no referential integrity. You cannot say, hey, that student ID I stored with my grade better be an ID in that table student. It just does not have that. Mongo doesn't support this notion. But it does support indexing. So things we're used to from relational databases. You can have indexes. They are the main way to speed up performance is you create indexes to support your common queries. And the other difference of Mongo from non-relational databases is that in some databases you store kind of a key blob. Maybe you're thinking of something like maybe a Redis or maybe files where there's really the database engine doesn't know what's inside your data structure. But in MongoDB, it does. In MongoDB, the engine knows what's inside documents, so you can index specific fields. You can query and fields within a document. So a document is really a first-class data structure that the engine understands, even though two documents in the same collection can be completely different. And we'll see that a little bit later. The main reason for thinking of we need a document-oriented database was this impedance mismatch. It was invented by developers who thought to themselves, why is it that in my programming language, C, C++, Java, C#, whatever, why is it that I have classes and objects, but in the storage layer, I have to spread them across into square tables and then do all this business of relation of foreign key references and stuff like that to stitch them together. And that seems a bit odd when you think about it. Most of us didn't think about it much. So I have in memory, I have a class of order, right? So the order has some kind of identifier, maybe the order ID or something like that. And it has a list of order items. Each order item in itself is maybe a triplet of having a SKU number and the quantity and the name of the item, maybe the price of it, right? So each order item is an object, right? And then there's a list or a collection or a set of these objects. And then there's an address. Address has several things, line 1, line 2, line 3, things like that, right? So all of this is richly deep, or could be very deep, but it is not just individual fields that have a scalar value. Fields could have a list of things, or they could have sub-objects under them. But when we're trying to represent it in relational, we're spreading that information that belongs to a single invoice into many, many tables. Why? Because that's how it's implemented. So is there use for that? Sure. Is it useful? Absolutely. Are we used to it? Yes, for 50 years we've been doing things this way. But is it the most efficient way to store a single invoice? The use case around an invoice is one where I usually write an invoice or read an invoice as a whole. So why am I going Easter egg hunting for the little pieces? Why aren't they stored in one document? So this is what we mean by this impedance mismatch, that the stuff in the blue box at the top had to be somehow shoehorned into the tabular model, or vice versa. Somebody made the tabular model, but the way the program or the business wants to treat an invoice is a single unit, and it had to reshape it completely. So Mongo said, well, let's do away with this. Let's look at a document in the database and just have its parallel in the client side. Just have them with zero translation between them, have the document as the business wants to see the order, it shall be stored. And indeed, the way Mongo stores things would be that if you had this class order in your programming language, then it would map it or encode it as a document in MongoDB and would store it something that looks like this, this document here. And this is a single document. There's no tables to join, no nothing. So if I want to call up an order by its ID, hey, give me the order with this ID. Boom, I got all line items, all everything just in once. If I want to write on it, same thing, write on that order, blah, blah, blah. If I wanted fast access and say by zip or something, I could throw an index on the ship2.zip that you see here and have it, the index will assist me in queries that want all invoices in a zip code or by customer ID or by whatever you want. So at this point, you might think, oh, I really love this, or I don't really like it, or maybe I want to hear more about it. But I have all of this relationship, all of this, invested talent in using relational databases. So my advice is don't throw relational databases away. All of this knowledge you have about the inner working of databases, about how to reduce I/O, optimizing queries, things like that, those notions carry over very well. What doesn't carry over is the modeling or the schema design. And I have a course on that, and you can find other resources around the net, the advisory on how to design your documents so that they work well with Mongo or work well for your business that exists out there. It's kind of an emerging area, not an area that we knew about 10 years ago or 20 years ago. So the advisories come from the field with people who deal with it day in, day out. And it is still somewhat under construction as we understand more and realize more at scale what it means to work with documents. I do want to say something, though, about relational databases, is that we have this ethos that relational databases, and especially normalizing data, has been so good for everything, and it's just the way to do things. And in reality, we all know, all of us who did relational databases, is that no matter what, we ran into essentially physical storage problems, essentially that the way we divided tables in theory and implemented the system the first time did not fit our use case, did not fit maybe the speed at which we needed to ingest or read data or join or things. And then we did all kinds of stuff like denormalize tables in order to read faster, because we had too many locks imposed, or because just the cost of join was too much, or we had to drop constraints, drop check constraints in order to speed up things, or we had to create sparse columns where, let's say a table had 6 extra columns that are nullable just because we couldn't do like a document and just add or remove fields as we want. The table has to be defined with all the fields we need. Or we had trouble upgrading schemas where it took hours or days to add a column or change column types or do things like that with relational databases. Mongo doesn't have all of these. You don't need to do anything to achieve any of this, because in Mongo, a document can have any number of fields up to a certain size, but any number of fields, and they can be completely flexible. You do not need to pre-declare a schema or anything. So if you use relational databases and you think normalization is the bee's knees, well, that's great. But if you worked in practice and you found that you needed to reach into any of these techniques to speed things up and to optimize, you really kind of turned your back on the relational model. You turned your back on normalization and had to do whatever you had to do to get the business going, right? In that case, I do recommend looking into Mongo, because you will find that the flexibility of the document might save you a lot of headache. So that's my 2 cents on that. So the first thing here, installation is a breeze. I'll just flip to demo really quick. Here I have a directory called fresh, and there's no data in there. It's just a bunch of empty directories, and any database needs to store data to a file. So that's what it is. Mongo comes as a set of binaries. So let's say see program files, MongoDB server. Let's take the version 5.0, why not? bin. So if I look at the binary distribution, it has this process here called Mongo, and it has a process called MongoD. Mongo is the shell, and MongoD is the daemon. MongoD is really the Mongo engine, the database, and it has zero footprint. There is no dongles, no Java to install, no C# to install, no nothing. All you have to do is have this MongoD in your path, and you can run Mongo. In fact, here we go. I'll say MongoD. Of course, it has any options, but I don't need to specify them all. I will do the simplest running of MongoDB. Installation, you just unpack the zip somewhere and you have it installed. There's also RPM packages and Windows MSIs if you want to install it as a service, but at its core, it's just a daemon. It's just a program. So I'll have to tell it where to store data. So I'll say --db path temp. From here it's called fresh. And let's say data. So I'll say store your data in this directory. And there we go. We have a Mongo process running. It's listening by default on a local port. So Mongo, the shell without the D, it's the shell. I'll just connect to this server. And you see, I'm not saying anything because if I don't give it any options, it's going to say, oh, connect to the network. Which network? Well, you didn't tell me, so I'll connect to the local network. Which port? Oh, port 27017 TCP. That's the Mongo port. Okay, so I'll just connect and we're in. From here, I can do things like show DBs, and it will tell me there are some default housekeeping databases. I'm not going to get into this right now. I can show collections. Collections is like a collection is like a table, and there are no tables. It's a fresh databases. There was nothing in the data. So, hey, I didn't create anything. There is no schema, no nothing. So sure enough, there's nothing. There is a notion of database. The database is kind of like a namespace. And indeed, in storage, each database or each collection will have its own kind of storage blocks. So there is a notion of a DB, and if I type DB in from the shell, it will say you're in the test DB. And in order to change to a different database, like say use demo, I can switch to the DB demo, and I'm in it. If I say show DBs, there is not really anything materialized yet because I haven't written any data. So if I go out and I show the content of the temp directory, there are some, housekeeping things lying around, but there really isn't any databases or any storage carved ahead of time, and definitely no schema. Let's create some schema. Use demo. I'm in the demo DB, so I'll say db.foo.insert. ID is 1, name is Bob. And it says, hey, I wrote something. So now if I say show DBs, it will say, oh, there is a demo DB. Sure, it has very little in it, just this one document, but now I have carved out some storage. And if I'll go to the directory, you'll see some more stuff, but that's about it. Which means now I can actually kill this server, right? And if I start it again, and I go here, and I show DBs, it shows demo is still there. Show collections. I have a collection foo, and db.foo.find tells me that I have this document stored in there. So far, so good, I hope. Okay. If there are questions and stuff, maybe drop them in the chat or barge in. I'm kind of going along and hopefully clarifying things, but I'm happy to answer questions as we go along.
There are no questions in the chat right now.
Okay. So I did show you here on screen that this looks kind of like this braces notation, and the astute observer will say, hey, this is JSON. So MongoDB stores JSON, and that is not true. The data format that Mongo uses is called BSON, and BSON is a binary serialization object notation where JavaScript's JSON is a string-oriented representation of JavaScript types. The difference on types is actually pretty important because the native BSON types map directly to the C types, meaning if you stored an int, it's an int, and a uint is a uint, and things like that. So mapping, decoding the data that is stored in the database, in the I/O blocks at the lowest level, all the way up to the client and on the wire representation when it's transmitted over the network to your client, all of that is done in BSON, which minimizes the amount of translation and encoding and decoding that needs to be done. So BSON is fairly compact. It is flexible like JSON because it's just a bunch of names of fields with their field values verbatim, serialized into one long byte buffer. And it is efficient to traverse. You can just skip because fields of variable things have predictable length. So it's efficient to traverse, it's efficient to encode and decode, and it's fairly fast. It's not the fastest. If you did have a schema and you knew that the offset for field X is 10 bytes from here, you'd actually not need to store this offset with every document, so it will be faster. But this strikes a balance between efficiency of encoding and flexibility. JSON, on the other hand, limited data types. There's only like 7 data types in JavaScript. Of them, maybe 4 that are for data. You know, you have number, you have string, you have object. Even arrays are kind of object. So there's very limited data typing, especially around numerics, like floats versus integers, long integers, decimals, things like that. So it's much more limited. It is stored as text, meaning that it is not a byte stream. Well, it is, but at the end, but the translation of a number encoded in JSON into the native C number will still take some decoding and algorithm because it is not just the 4 bytes of int32 or things like that. So you would have to kind of traverse the whole JSON string in order to construct a data structure. Whereas with BSON, in theory, if you wanted field A or field B, you could just read the buffer up to that point that you found field A and you're done. Anyway, so I showed you databases. There is a notion of a database. It's a namespace. Databases are kind of a scope where you can define users or operations at the database level, but they're not more than a namespace. The one process hosts all logical databases within the process. And then we can create a document by using the insert command. And here I showed you that we created a document for a person named Bob, right? What if I wanted to create Bob again? Well, it's saying duplicate key error, ID is already existing. So from here, what you know is that Mongo has the notion of some kind of primary key. And in fact, this is the only schema rule in Mongo, is that every document you create, insert, whatever, every document must have an ID. And the name of the ID field in Mongo is _ID, just like that. So that's immutable. This is the ID. And no matter what, that has to be a unique value. Now, value itself could be actually pretty varied. I can have 1.1, and I'll just call it Bob.1. Why not? That's totally available. So you'll notice that this one is kind of an integer. It's probably a 32-bit int. And this one is actually a float. So Mongo knows the difference between these things, and it will show it. So db.foo.find. I have two Bobs. Well, I have Bob and one. Bob.1. They have these. Notice here that the data type of the ID is different, and also the IDs themselves don't collide. If I wanted to do a 1.0, there's a way to do it. Oh, this is translated to float. I can make it into a different data type and coerce it in, but my point is that the data types here are different. They do not have to be. Actually, I can have also this one, which is a doozy. This is a string with a value of 1. So here, I'll have it from the top. Now I have two Bobs that have the ID 1, but one of them is a string 1 and the other is the number 1. It's probably a double or something. So there's all of this stuff. I can even have, it doesn't have to be anything numeric, right? I can have an ID of Kim and with a name of Kimberly, let's say, and that's just fine. Okay, so you must have an ID, but its data type is not predetermined. You can have even a compound ID, like have it an object that says the month, comma, the year, or things like that. The only thing it can't be is it can't be an array, and it has a length, maximum length of, I don't know, 700 bytes or something. But other than that, it's pretty open. And at this point, somebody in the chat will ask, hey, do you have identity? And the answer is no. Mongo does not support server-side identifier generation. It doesn't have a notion of a sequence column or anything like that. You could construct a synthetic sequence column by creating a table and pre-populating it with numbers, or by having a collection with a number you keep incrementing or something, but that would be two transactions against Mongo. You'll have to implement it client side. What is common is to just do things like this. I'll omit the ID altogether, and I'll insert a person named Og. And it says, good, you can do it. Now, if you notice, I just violated my own rule. Every document must have an ID, and I provided a document that has no ID. If I say find, though, you will see that Mongo did assign an ID to this new person, Og. So this looks like it's a ID generated by Mongo. I want to emphasize it is generated by Mongo. Haha, it's Mongo the client. It's this shell that is generating it, not Mongo the server, not MongoD. MongoD requires an ID. If I send the correct byte incantation to Mongo saying insert this document and that document doesn't have an ID, the server will reject it. What happened behind the scenes when I said insert is that insert is actually a JavaScript little scriptlet that interacts with a driver. And somewhere at the bottom here, you will see these lines, and it says, if the object given to me, this document that you supplied this function, obj, if that if that object happened to not have an ID, then create a object with assign a new object with the object ID, and then copy all of the things from the document. In effect, add an underscore ID to it. So here we go. The Mongo client actually looked at my silly insert and said, Oh, you wanted to give me one without an ID? Haha, I'll add one for you. But Mongo, the server, does not have a notion of a sequence, neither does it have a notion of generating an ID automatically. It's all done by clients. If I wanted, I could have a UUID, so I can have a underscore is say UUID with a name of Ben, and here we go. Now I have Ben with a UUID, otherwise known as a GUID or whatever, however we pronounce that. Okay, so client generated IDs. Questions on that? Cool. So I have documents. I've inserted them into a collection, and I can retrieve them by issuing a find, and I can update them. So once they're existing, I want to update a document. I want to say add a field, and this is where things become interesting and useful, because I created Bob, and now I want to give Bob some approval or something. So I can say db.foo.update somebody with the name, or let's say ID of 1, and I want to set the approved to true. True is a Boolean. That translates into, you guessed it, a BSON data type of Boolean. And it says, hey, I found someone with the ID 1 and I changed it. If I do this again, it will say, hey, I found somebody with the ID 1 and I haven't changed it. Why is it doing that? Well, it's smart enough to know that Bob already has a field that has approved true on it. So there's no need to change anything. Why write the document again? Why create more IO pressure? It already knows it's there, so no need to change anything. So it's pretty smart about that. I could maybe add some points to people. Let's say I'll update the person with the ID Kim, and I will set Kim to have 3 points. So now I have Kim, whose name is Kimberly, and I added 3 points. What you notice here, and as well as Bob, is that this $set operation added a field and didn't touch any of the other fields. And that is important because I want to be able to surgically just change specific fields and not touch the other ones. Other databases may tell you that in order to mutate, to change an existing document, you have to submit a new document version that has all the fields you want with all the values. So what effectively is happening is the client has to read the document as it is right now, change some fields to its heart's desire, and then submit the whole new document to be saved as is. That is maybe sometimes useful, but it is very dangerous for concurrency. Imagine 2 clients wanting to add a point to Kim. They're both reading at the same exact millisecond. They're seeing that she has 3 points. I add 1 point, you add 1 point. So each of us just submits a new document with a value of 4. Well, that's not right. If me and you both added points to Kim, she should have 5 after both of us awarded her 1 point. The way to do it in Mongo, of course, would be to use a surgical operator. It's inc. It says increment the number of points that Kim has by 1. So if I issue this, I'm issuing a command to Mongo, say, hey, server, you do the math. You figure it out what it is right now, incremented by 1, and do it atomically. So it's effectively within a transaction, it will be incremented by 1. And if 2 commands are received by Mongo, then 2 points will be added here. I'm adding this, and then somebody else is adding 1, and then db.foo.find Kim will have 5 points. She had 3. I added 1 point twice. I incremented it twice, so now she has 5 points. All right, so very important for concurrency control. If you're developers, please avoid reading the whole document and slamming the new document. Please use surgical updates such as this one. There are surgical update operators to set a field, remove a field, add items to an array, remove items from an array, all of this nice stuff that you can do atomically and under a single transaction. Now note that if I wanted to update, instead of just Kim, but I wanted to update everybody, meaning not just whoever had the name Kim, but whatever matches, whatever in there, and give them all 1 extra point, I could use the update many. And it indeed says, hey, you had 6 people here. I added a point to each. Okay, as expected, those with points got a point added. Those without points just got 1 point. As expected, this is good. I told you that it's doing the update under the guise of a transaction. In fact, this type of update that I just did, without wrapping it in an explicit transaction, will affect each document on its own. Meaning that, in theory, Mongo could fail to update Kim or fail to update Og, but succeed on the other ones, and it will be just as happy. It will tell you, yep, I updated some people, some I failed, but that's it. There's no transaction rollback or anything like that. With Mongo 4.0 and above, now that we have multi-document transactions, you can wrap this in a transaction and say, update them all, or whoever matched your criteria, update many documents under the guise of a transaction, and behave like if it all succeeded, commit it, and if not, then erase it, roll back or unapply it. So creating the effect of saying do it all or none at all. So that's a possibility that exists now, did not exist prior to 4.0. So that's possible. So I did that. There's update 1, there's update many, and we can also create an upsert. So in theory, if I came in and I wanted to, let's say update 1, the one with the ID of Jan, I want to set the name to Janice, and the points, they all get a 12-point bonus these days. So if I just did this, it says I didn't find anyone with the ID of Jan, so I didn't do anything. I didn't modify anyone, I didn't find anyone. But if I wanted to have this notion of upsert, I could just add another option. And at this point, it says, if you didn't find somebody with this ID, then create this document. And this, again, is an atomic operation, which means if Janice is signing up from her mobile and browser at the same time, we might get some kind of race condition, but Mongo will only insert once because I gave it an ID of Jan. So that means that by carefully choosing my ID, I can sign up users from multiple things and avoid collisions. And if I repeated the same operation, it will say, I found one with an ID 1, but what you told me to do is already done, so I don't need to modify. So it's concurrency safe. Okay, so that's going into the weeds of updates, just so you know, think about concurrency, things like that. Update many, I talked about, I just showed you that I gave everybody extra points, and indeed people get their points. Questions so far? Okay. I'll just check here. I'm just going to show a couple more features regarding data types. So I could have a data type of an array, and arrays in Mongo can behave either as a sequence or as a set, meaning the position of an element in an array could be meaningful to you or not. It's your choice. So db dot array dot insert, I'll put in a document, let's say with ID of 1 and points array this time of 1, 4, and 5, 1, 3, 5. And I'll have another one with other points. I don't know, hit the keyboard, Nuri, boom, boom, boom. So now I have these two documents here in the ARR, and they both contain arrays, and that's totally fine. Mongo is happy to do that. It'll just store a value of a field as an array. How big can the array be? As big as you want. Mongo does have a limit on the size of the document, which is 16 megabytes. I would say if you get anywhere near that size, I would like to have a conversation about why a single document will have that much payload in it. It might be a smell test that you can split the document, or using Mongo plus a file system if you want to do something else. Anyway, you can have arbitrarily large arrays. I recommend them not having them huge. There's some performance impacts, but certainly tens and hundreds is just fine. So we have arrays with points, and I can say things like find me, db.arr.findme, arrays where the documents where the points have the somebody who has 2 points. So here, what I expressed is that I want to find somebody who, in their points field, there exists a value 2. All right. So it's not saying give me someone whose points is exactly this array. I gave it a scalar 2, and I could use 3, and I would expect that both would come back, right? And by doing that, I told Mongo, go give me all documents where the 3 is an element in the field or is the value of the field, right? So in this sense, it treated the sequence without it treated it as a set or a collection that has elements. You can see that in the second array here, this is not a set because 3 is not unique. I can say things like, if I want to update arrays, I can say update the points, and I'll say update everybody's points. No criteria. I'll say $push onto the element point field points the value of 4. I'll say update many, so it will touch any that match. And it says I added the value 4 to the points array for many of them. So it added 4. And if I will repeat that, you will see that the element 4 will appear twice. But I could also do a smarter thing if I wanted to use it as a set and not just to add an element. I could say add to set the value 42. And now everybody has 42. If I'll say add 42 again, add to set, you'll see that the modified count is 0 because the element 42 is already there. And if you treat this array as a set, you will not be adding an element if it already exists in there. So smart use of arrays, you can do this. You can, of course, say, find me somebody whose points are exactly 1, 3, 3, 5, 4, 4, 42. And it will return this one document that has this array exactly. And if I omit or mangle this somehow, it will return nothing because nobody has this points array that verbatim contain this array value. So it knows how to treat arrays in many interesting ways. So you can use that for your application logic. Okay, we're kind of getting towards the end here, so I'll talk about a couple more Mongo features in general. First of all is replica sets. A big difference between Mongo and traditional databases is Mongo from day one was designed for scale and designed for running on commodity hardware, meaning not terribly expensive hardware, with the idea that you'll have a cooperating network of database daemons that together form a single logical database. Replica sets are part of this. Replica sets provide durability and availability. What's the problem with commodity hardware? Well, it's cheap. It crashes more because the hardware is cheap. So the idea with replica set is instead of you writing to a single database and the disk being oh so expensive that it will never lose anything and RAID arrays and stuff like that, why not have a few cheaper computers, let's say 3, and the chances of all 3 of them crashing is very low. But in the event one crashes, the other will take over and become the live database. So automatic failover hot standby is the idea of a replica set. All data that is written to the replica set is written to all data nodes of the replica set. Minimum replica set size is 3 because of how math works. And how they form elections and stuff. But what you need to know about replica sets is that really they are for durability and availability. Durability, namely that the data you wrote, once it got acknowledged, really gets saved to disk somewhere. And even if one of the nodes failed, it's written elsewhere. Therefore, the data is durable. If you reboot your cluster, the data is there if you got acknowledgement that it made it. And availability, being that it's automatic failover, it means that once any node fails, the others take over, so your client can continue on, just reconnect and continue on its merry way. All data is there. You don't need to wake up at DBA at 3 a.m. and ask, oh, can you do the failover procedure, da-da-da. It's all automatic for you. What replica sets are not? They are not for capacity. So having a replica set of 4 nodes does not contain more data than 3 nodes because it's the same exact data that gets written to each one of the nodes. So it's really for durability and availability, not for capacity increase. Throwing more computers into it won't make you go from 1 gigabyte to 10 terabytes. That's not going to increase capacity. And the second is it does not increase your write performance. So if you're encountering performance issues with your current Mongo cluster, you will either scale up the nodes or you would go to sharding, which I'll explain in just a second. Let's see, do we have enough time for a demo of how to create a replica set? It's almost as easy as running a...
Yeah, we have a few minutes.
Okay, so I'll create a replica set here. Why not? So I'm nuking all the data that we've maybe previously wrote, and I'll start Mongo daemon. So Mongo d -- db path is temp fresh a. And because I'm going to create a replica set of 3 different daemons, each one will need to communicate on the network. I'll need to tell it what port. So I'll say port 30,001. I chose it arbitrarily. Any TCP port that is open is fine. So I'm going to say, okay, do that. And also REPL set R1. So I'm going to tell MongoD, you're going to start in replica set mode. Here we go. It started. I'll start another one. Same replica set, but a different port, and I'll need to give it a different data storage directory to store its files, because presumably these daemons run on different machines altogether, but on my local machine, I need a folder. Here's a second one. And here's a third one on port 30,003. So I have three MongoDs running. At this point, they don't know about each other. I'll have to somehow teach them to do that. So I'm going to say Mongo. I'm going to use the Mongo shell, but in a special way, eval. I'm going to tell it to run on port 30,001. That's the first daemon I raised. Eval rs.initiate. What is Mongo port? -- port. There we go. And it says, oh, you told me to initialize a replica set. You didn't tell me about my buddies, so I'm assuming I'm the only one in the replica set. So that was my first node. If I run it again, it says, yep, already done. And now I'll have to tell it, after it initialized, to add another node. So it's local host 30,002. And localhost 30,003. Those are the other 2 nodes on this machine. And at this point, if I go and say rs.config and show the members, it will tell me that the replica set, it created a replica set of 3 nodes, each one running on its own port, and they're all happy and talking to each other. Actually, I don't know that, but I can say, show me the status. And it will tell me that it has 3 live nodes and all kinds of statistics. Not going to get into that. What maybe will be more interesting is going into my replica set. And you will notice that I connected to the first node, and it happens to be primary. Way a replica set works is a single primary at any given point in time. They heartbeat each other and talk to each other. And if the primary dies, then a secondary will take over. My prompt here shows me that I'm on a primary db.foo.insert. I don't know, name is Bob. I inserted a document. I'll insert also Kim and Og. I'll exit here, and I'll connect to a different node, maybe to the 3rd node. And you will notice my prompt says I'm in the secondary, on a secondary node. So I'll say db.set secondary OK. It just ignore this. This is just junk that the shell is preventing me from querying unless I acknowledge that I'm reading from a secondary. db.foo.find. And here we are. We're on the 3rd node, and all the data is there. So, dear diary, we just created a replica set. Again, no big Java configs, no big dongles to install, licensing CDs or anything. Fairly simple. Just one Mongo daemon configured right creates a replica set. Okay. Lastly, I'll talk just a bit about sharding, and I think we'll take questions, and we're kind of up against time. So sharding is Mongo's scale-out technology. Sharding takes collections. Let's say I have a collection of people, and I want to shard it. I create a sharded cluster, which relies on replica sets and configuration. It's more involved to set up. What it does is it takes this collection you're sharding and chops it up horizontally, putting some of the documents on shard 1, some of the documents on shard 2, and the other documents on shard 3 without overlapping, meaning that a single shard, a single set of machines, will only contain a subset of the data. By doing that, when I query, say, for people whose name begin with A, I may land on shard 1, and people whose name begin with B may be on shard 2. So you're really dividing up the workload of queries and inserts and spreading it across your shards. So whereas before, if I'm hitting against a write capacity, I had to go scale up my MongoD in a replica set. In sharded clusters, I can add additional shards when my workload becomes too much for a single shard to handle. So by partitioning my tables or my collections across multiple machines, I'm letting them each handle less work, which translates to if I need more capacity, I can just add more shards. The data will be split automatically and spread across the servers. And then I'll be able to handle much more data, terabytes, petabytes, whatever. It's a much more involved process. It does shard automatically. There are things you need to know about how to partition and how to choose a good partitioning key. But at the bottom of it all, you're still using commodity hardware to the degree you want to fund your operation. And you are spreading your data across many machines, which gives you more resilience and gives you also the ability to scale up your workloads. In theory, ad infinitum. I'm sure there's some physical limits, but that's about it. Okay. Cool. So that's all I've got for today. I guess if you're a programmer, you may ask, how do I use it? Is it ODBC drivers? Nope. There are some specific drivers Mongo produces for your favorite language: Python, Java, C#, JavaScript, Go, things like that.
Which one would you recommend?
The language you like. I would recommend use the language you like. The language choice, like your choice of Java or C or something, is up to you. Mongo server talks through the protocol, so it doesn't matter for anything really performance-wise. I would, I guess, add a caution to those of us using the mean stack and thinking that in JavaScript you need to use Mongoose as a driver. Mongoose is not a driver, it's an ODM, an object data mapper, and it kind of hides away from you what I showed you with updates and things like that. So it kind of takes you away from being most efficient with the command layer of Mongo. I recommend against using that unless you're like really crunching time and doing a desktop side project. If you're doing big projects and performance is important, I recommend using the JavaScript driver itself and not using ODMs or ORMs, which may slow you down or do operations not the best way. But language, you know, whatever language you like, use that.
Thank you, Nuri. That was very informative.
Thank you.
Do we have any questions from the audience?